When it comes to oil and gas, drilling the well is really just half the story. So today, we're going to dig into that critical final step, the part that makes it all actually work: wellbore completion. So picture this. You've just poured millions of dollars and months of hard work into drilling a well, and boom, you hit the jackpot, a reservoir thousands of feet underground. But now what? Seriously, what's next? How do you actually get that oil or gas from way down there all the way to the surface? How do you build that final crucial connection? Well, that's exactly where wellbore completion comes in. It's all the complex engineering that turns a simple hole in the ground into a super valuable productive asset. And let me tell you, if you get this part wrong, the entire project could be a complete bust. Okay, so here's how we're going to break it down. First, we'll talk about why this final connection is so darn important. Then we'll take a little trip back in time to check out the original open hole method. After that, we'll jump to the modern standard, the cased hole method. We'll put them head to head and then figure out why the industry made the switch. All right, let's jump into section 1, the final connection. See, when you find a reservoir, the rock itself, how porous it is, how easily stuff flows through it, that's a given. You're stuck with it. You can't change geology. But what you can control is the engineering, how you actually choose to tap into it. And this right here is what's so wild. This one engineering choice, it can be the difference between a gusher and a total dud. We're talking about a multi-million-dollar decision that can literally make or break the entire operation. Okay, on to section 2. Let's rewind the clock a bit and look at the original approach, the open hole method. Honestly, you can think of this as the most straightforward, no-frills way to get to the oil. Just drill and let it flow. The process seems almost too simple, right? First, you drill down right to the top of the reservoir. Step 2, you secure the well by cementing a big steel pipe, that's the casing, down to that point. And the final step, you just drill right through your target zone and leave the whole thing wide open. But of course, there's a catch. And it is a big one. This method only works in what engineers call competent rock. Basically, rock that's hard and stable enough not to just collapse on itself. If you try this in some soft, crumbly sandstone, yeah, the whole well would just cave in. Not good. So the upside is pretty obvious, right? It's cheap and you get this massive open channel for maximum flow. But the downside? Oof, it's a real deal breaker in a lot of situations. With an open hole, you have practically zero control. Unwanted water or gas can just flood right in, and you've got no way to target specific juicy layers of the reservoir. This lack of control, it's a huge operational nightmare. And that huge problem, that lack of control, is exactly what led to the big innovation we're talking about in section 3, the modern standard. This is the cased hole method. It was literally designed from the ground up to fix all the things the open hole method got wrong. Now, the process here is way more surgical. First, you drill completely through the reservoir. Then, and this is key, you run that steel casing down the entire length. You're completely isolating the well from the rock with a solid barrier of steel and cement. And then comes the magic part. You use these precisely engineered explosives, called shaped charges, to blast these clean, focused tunnels exactly where you want them. And that's the genius of it right there. Perforation isn't just blowing stuff up, it's precision engineering. It's like you're installing these tiny, specific doors between the well and the reservoir. It lets you choose exactly which parts you want to open up and produce from. Okay, time for section 4. Let's put these two methods right next to each other, head to head, and really see what makes them so different. Yeah, this table really lays it all out. Look at the casing point. The open hole method stops above the reservoir, while the cased hole goes all the way through it. And that one difference changes everything about the connection. You go from a wide open rock face to these precise perforations. And that's the real heart of it, isn't it? The jump from low control to high control. That one factor ends up determining everything else. What kind of rock you can use it on, and, of course, how much it's going to cost. So it all boils down to a classic engineering trade-off, really. Do you go with the simpler, cheaper option that kind of leaves you flying blind? Or do you invest in the more complex, more expensive method that gives you absolute pinpoint control? And that question leads us perfectly into our final section, the great shift. I mean, if the cased hole method is more expensive, why on earth did it become the undisputed industry standard? What made it so much better? Well, the first big reason is all about managing the junk you don't want. Reservoirs can be pretty messy, you know? They often have these layers of useless water or unwanted gas mixed in. With a cased hole, you can just choose not to perforate those zones. You keep the doors shut to the bad stuff, which means you produce more of what you actually want. Reason number two is the flip side, targeting the good stuff. See, not all parts of a reservoir are created equal. The cased hole method lets you focus only on the most productive sweet spots. Plus, it gives you the option to go back later and treat specific zones to get them to flow even better. That's something that's just flat out impossible with a wide open hole. And finally, we get to the reason that pretty much trumps everything else: safety. I mean, think about it. Putting multiple barriers of solid steel and cement between your crew on the surface and a high-pressure reservoir miles underground, it's just fundamentally safer. It gives you a level of control and containment that an open hole could never, ever match. Yeah, a quote from one of our sources really sums it up perfectly. It says, "The industry shifted because those long-term benefits of control, being able to manage production better, and of course being so much safer, were just worth way more than the short-term cost savings of the old method." So, let's wrap this up. What are the big takeaways here? First, wellbore completion is not some afterthought. It's the critical engineering decision that basically defines a well's success. Second, that old open hole method? Yeah, it was simpler, but its total lack of control made it a pretty risky and limited tool. And finally, the modern cased hole method. Sure, it's more expensive, but it won out because it delivered what the industry desperately needed: precision, flexibility, and most importantly, safety.
And that leaves us with one last thought to chew on. This whole choice between open hole and cased hole, it's a perfect example of a fundamental trade-off we see everywhere: simplicity and low cost on one side versus complexity and high control on the other. So where else do you see that exact same choice shaping our world? Whether it's in technology, manufacturing, maybe even in our own daily lives.